Okay, what I would like to do now is summarize the results of the previous two videos. One was, groups of 2, the other was groups of 3. Summarize them in a little table because I want to show you something cool. Okay, so what I've got here is, in this column, the total number of objects. This will be the total chosen. Okay, so this would be, I have 2 objects and I'm choosing 2. Remember we had Simon and Alvin. How many ways could we choose 2 to go to the store? Well, there was only one way to do it. 2 choose 2 is 1. If I had 3 when I brought in Theodore, all of a sudden we had, let's see, what did we have? We had 3 choose 2. Yep, we had 3 ways to do it. 3 ways to choose 2 brothers. If you had all 3 of the Alvin, Simon, Theodore, there were 3 ways to pair them up. You might remember Alvin with Simon, Alvin with Theodore, Simon with Theodore. There were 3 ways to pair them up. If we brought in a 4th chipmunk and we wanted to figure out how many ways to choose 2, it was a 6. And then we got a 10 if we had 5 chipmunks. And if there were 6 chipmunks, we were up to 15 and so on. Now there's a definite pattern here. 1, add 2, you get to 3. Add 3, you get to 6. Add 4, you get to 10. Add 5, you get to 15. Add 6, you get to 21. Add 7, you get to 28, and so on. All you do is you keep adding 1 coming down this column. So you could figure things out, like, oh, if I had 8 of them, 8 chipmunks, how many ways could I pair them up? Make pairs. I could make 28 different pairs of chipmunks. And again, order doesn't matter here. A pair is just 2 chipmunks put together in some way, grouped together. And so on. So this is kind of a nice little pattern. Now we started looking at choosing 3 objects. That was the barn animals. Now if you only have 2 barn animals, you can't choose 3, so we don't have anything to put there. But if you had 3 animals, how many ways could you choose 3 of them? There was only 1 way. And then when we had 4 barnyard animals, we ended up with 4 total groups of 3. And when we had 5 barnyard animals, we had 10 different ways to get 3 of them. And when we had 6 barnyard animals, we had 20 ways to choose 3 of them. And that's as far as we went, so I'll stop there for now. Now, let's look at these. You can kind of fill some of these in. If I had 4 thingies and I wanted to choose a group of 4 thingies, there would only be 1 way to do that, right? And if I had 5 thingies and I was going to choose 5 thingies, there would only be 1 way to do that, and so on. Now, I got enough here to show you the pattern. The pattern of life. This is a big pattern. This is huge. Okay. Actually, it starts with this pattern. This column, we already saw this pattern. You go 1 plus 2 plus 3 plus 4 plus 5 plus 6. Okay. Notice that 1 plus 2 is 3. Ha! See what I just did? 1 plus 2 is 3. 3 plus 3 is 6. 6 plus 4 is 10. 10 plus 5 is 15. Isn't this fun? 15 plus 6 is 21. Woohoo! 21 plus 7, 28. Woohoo! It works over here too, folks. 1 plus 3 is 4. Woohoo! 4 plus 6 is 10. Woohoo! 10 plus 10 is 20. Woohoo! And you just keep going. 20 plus 15 is 35. 35 plus 21 is 56, and so on. Now this is a whole lot easier than getting out a bunch of barnyard animals, don't you think? And you can complete over here as well. 1 plus 4, that's a 5. Meaning that if I had 5 thingies, whatever they were, how many ways could I choose 4 of them? There would be 5 groups of 4 possible. 5 plus 10 is 15. Woohoo! 15 plus 20 is 35. Woohoo! 35 plus 35 is 70. Woohoo! And that means, the 70, that means that if we had 8 woodland animals, and we were choosing 4 woodland animals from that group of 8 to go to the store and get donuts, there would actually be 70 different ways to do that. And it just keeps going. 1 plus 5 is 6. 6 plus 15, 21. 21 plus 35, 56, and so on. Now, actually, this has a name. It's called Pascal's triangle, and I'm going to take a wild guess that Pascal's the guy that either invented it, discovered it, played with it a lot, something. But usually it's actually written this way. It's written as a triangle. So you'd have a 1 and a 1 and a 1. Okay, bear with me now. Now what you do is you go 1, and then you add these two that are diagonally above you to get a 2. And you put a 1. 1, add these two to get a 3, add these two to get a 3, put a 1. So you always have a 1 at the end, and then you go 1 and 3 is 4, 3 and 3 is 6, 3 and 1 is 4, always a 1 at the end. 1 and 4 is 5, 4 and 6 is 10, 6 and 4 is 10, 4 and 1 is 5, there's a 1. 1, 6, 15, 20, 15, 6, 1. And you can go as far as you want. I'm going to go one more just for fun. 6 and 15 is 21, 15 and 20 is 35, that's a 35, 21, 7, 1. Change my mind, I'm going to go one more. 1 and 7 is 8, that's a 28, that's a 56, that's a 70, that's a 56 again, that's a 28 again, that's an 8 again, and a 1 on the end. Now, if you bring back this table of numbers, it's kind of like if you put it this way, you can kind of get it to line up. In other words, here's 1, 2, 3, 4, 5, 6, 7, 8. Here's the 1, 3, 6, 10, 15, 1, 3, 6, 10, 15, and so on that we found. This was choosing groups of 2, recall. And then here's the 1, 4, 10, 20, 35, 1, 4, 10, 20, 35. So here's the groups of 3 going this way. Messed it up, but you get it. Groups of 3. So can you guess what this is? Groups of 4, groups of 5, groups of 6, groups of 7. So what you do is you kind of do it this way. This is how many groups you're choosing, right? This would be, I guess, groups of 1. Just the pattern, the math is always a pattern. 3, 2, 1. This would be groups of 0. I'll just put an of 0 here. Groups of 4, groups of 5, groups of 6, groups of 7, groups of 8, and so on. Okay. Now, what the rows are is how many you had to begin with. In other words, how many were you choosing from? So this is choosing from 0, from a group of 1, from a group of 2, from a group of 3, from a group of 4, from a group of 5. So you could say, I had 4 animals. I was choosing 1 at a time. There's 4 ways to do that. I had 4 animals. I was choosing 2 at a time. There's 6 ways to do that. I had 4 animals, choosing 3 at a time. You'd actually be back to a 4, and so on. If you want, yeah, I like this idea. So start counting at zeros is the idea. Make your triangle with the 1s and add up the diagonal elements. You can just kind of make one of these, and then you say 0, 1, 2, 3, 4, 5, and so on. This is the number in the pool of objects. And then come along this way, groups of 0, 1, 2, 3. This is how many you're choosing. Let's grab a random element, figure out if we can, what is this then? This would be 0, 1, 2, 3, 4, 5, 6, 7. 7 objects, and I'm choosing how many? 0, 1, 2, 3, 4, 5. This is 7 objects. Choose 5 to go to the store. You can do it 21 different ways. Let me do another one. How about this one? What's that? 0, 1, 2, 3, 4, 5, 6, 7, 8. This would be you have 8 objects and you're choosing how many? 0, 1, 2, 3, 4. You're choosing 4 at a time. So if you have 8 woodland animals and you're choosing 4 of them to go to the store, how many ways can you choose a different group of 4? There's 70 ways that you could choose a different group of 4. So this makes a nice little, sort of like a poor man's calculator. By the way, you can also find these things on a lot of calculators. If your calculator costs at least 10 or 15 bucks, then you should have a button on it. Boy, where is it on this one? Yeah. Should have it. There it is. Okay, I found it. See that little NCR? I don't know if you can see. Nah, you probably can't see that. If I do this, will this work? Can you focus on that? Anyway, if you find a button on your calculator that looks like this, let me turn this over now. If you find a button on your calculator that has this sort of a notation on it, if your calculator cost more than $10 but less than $50, you'll probably have something like this. Then what you can do is you can use that button to figure these things out. So like, for example, I can put in, let's see, what did I have? I had 8 choose 4. Okay, if I want to calculate 8 choose 4, then the way I do this on my calculator is first I hit the 8, and then I hit the NCR button, which on this particular calculator I would have to actually hit a shift NCR, but whatever. And then I would hit the 4, and then I would hit the equals. So let me do that. 8, NCR, 4, equals. And it's telling me 70. That's what my calculator tells me. Lo and behold, that's what my Pascal's triangle told me. So if you have a calculator with an NCR, you're in good shape. You can just crank these things out. If you don't have a calculator with an NCR button, then that's okay. Just make one of these triangles and you're just as good. Poor man's calculator. Just as a final note, there's also a button on your calculator that says NPR. Just don't even worry about that for this week, okay? We're doing combinations, which is NCR. That's the button you need. Pascal's triangle. What a cool thing.